Today we are going to look at these special parallelograms. There are three kinds of special parallelograms. There are rectangles, rhombuses, and squares. For rhombus, the plural might be written as rhombi or rhombuses. I have looked into it online and I've seen both options, so just know that you might see it as either one of those. So for rectangles, a rectangle is a quadrilateral that has four right angles. So if you know that you have four right angles in a quadrilateral, then you know that that quadrilateral is at least a rectangle. Rhombuses are quadrilaterals with four congruent sides. So if you know you have a quadrilateral and you know all four sides are congruent, you know for sure you have a rhombus at least. Now I say at least because knowing that you have four right angles, you could possibly have a square. Knowing that you have four congruent sides, there's a possibility that it's a square. So if you know that you have four congruent sides and that you do have also right angles, then you would know that you have a square. A square is both a rhombus and a rectangle at the same time. A square is a quadrilateral that has four right angles and also has four congruent sides. So as we're looking at descriptions of shapes and trying to decide which of these shapes we might be looking at, know that if you have a rhombus trait and a rectangle trait, then you probably have a square. I like to call them square babies because it's like a rectangle and a rhombus had a child and it has all of their characteristics. We're going to look at the quad family tree and look at more special characteristics for rectangles and rhombuses and squares. This is the quadrilateral family tree, and we normally study all of these quadrilaterals. Today we are only going to be looking at parallelograms in particular and the special parallelograms. Parallelograms, which we looked at yesterday, have opposite sides congruent and parallel, opposite angles are congruent, the diagonals bisect each other, and the consecutive angles are supplementary. The special parallelograms, which are below the parallelograms on this family tree, also will still have those properties. So a rectangle has all of these properties going for it, and so does a rhombus. So keep in mind that everything from above will also apply to them. When you know you have a rectangle, the definition is that they have four right angles. And they're also congruent because all right angles are congruent. And what else is special about a rectangle is that the diagonals will be congruent to each other. So if you drew in those diagonals, they would be equal to each other. And they're not only equal to each other, but they're bisecting each other, like back here for the parallelograms, which means that all four pieces of the diagonals would be equal to each other. And it also has all of the parallelogram properties that I mentioned before. For rhombuses, the rhombus definition is that it has four congruent sides. It also has diagonals that bisect their angles that they are touching. So I'll draw into those in a minute and go more detail on that. And the diagonals are also perpendicular. Squares have everything from above. So they have four right angles, four congruent sides, congruent diagonals, the diagonals bisect their angles, and the diagonals are perpendicular to each other. So I'm going to go back to these images, add a little bit of detail to them. So if I were to draw in the rectangle's diagonals, the full diagonals are congruent to each other. And also, before I draw the second one, I want you to notice that this one diagonal creates a right triangle. See how that has that right angle in the corner there. So you could end up doing some trigonometry or some special right triangles with that. If you draw in both diagonals and the diagonals are congruent and also bisecting each other, then all four pieces of these diagonals are congruent. And what it will do is it will create isosceles triangles. So this top angle here and here are congruent to each other because this is an isosceles triangle. And in these isosceles triangles, they also have congruent triangles, sets in them. So like that one there on the top and this one on the bottom, those are congruent triangles. And then this one on the right side and on the left side, those are also congruent triangles. And so we have two sets of congruent isosceles triangles. So these angles down here match those angles at the top, and then this pair of angles in these green triangles are also matching. And then keep in mind that these two angles in the corner are going to be adding to 90 because that corner angle does add to make a right angle. So there's lots of different questions that can be asked about rectangles. They have a lot of things going on. For rhombuses, if you were to draw in their diagonals, they said that the diagonals will be perpendicular to each other. So they're going to form a right angle. And that the diagonals bisect their angles. So that means that these angles here and over here, all four pieces are going to be equal. Because being a parallelogram, the opposite angles are congruent. Being a rhombus, the diagonal will bisect those angles. So then you have four matching angles along that diagonal. You're also going to have four matching angles along this diagonal. And then having that right angle in the middle means that these two angles with the 1 mark and the 2 mark here, they're going to add to 90 because that, the whole triangle will add to 180. So there's, again, lots of things to remember based off of knowing the fact that you have a rhombus or knowing that you have a rectangle. Now for the square, all of this is true. And what that means is when I draw in the diagonals of the square, the diagonals are going to be making right angles in the middle because they're perpendicular to each other. They are going to bisect these angles that they're touching. Now, bisecting a right angle means that you have 45-degree angles. And when I go to bisect these others, I'm going to get 45-degree angles again. So all of the small angles in this square, once you have your diagonals drawn in, they are all 45-degree angles. And then you have little 45, 45, 90 triangles inside of the square. You also have large 45, 45, 90 triangles if you were to think of just one diagonal like that. And in this case, the right angle would be this corner here, and then those would be the 45 and the 45. So you can use your special right triangles when you have squares. Let's look at some sample questions. Here is a rectangle sample, and in this one they've labeled a couple of the side measurements. They've labeled this piece of the diagonal here, and they've labeled DC. If AE is 15, then EC is also 15. And that means that that diagonal from A to C would be a length of 30. They've also given us the length of D to C as 24. Now this being a right triangle, we can use trigonometry. Actually, we don't have an angle here. We're going to use Pythagorean theorem to find the missing side. So 30 is my hypotenuse. So I'm going to call this x for a moment. So I'm thinking about x squared plus 24 squared equals to 30 squared. And I'm going to solve for x. So 30 squared minus 24 squared is 324. And then the square root of 324 is 18. So x is 18. So that means that this length is 18 for AD. So let's see what all we know. So AC is 30. BD is the other diagonal. And if we have a rectangle, remember that the diagonals are congruent. And that means that this piece will be 15 and 15, and that whole diagonal DB will also be 30. BE is 15, and AB is 24 because opposite sides congruent. And then BC will also be 18, just like AD. like we just found a moment ago. So that one involved the side measurements. This one at the bottom involves angles. So we have to remember that being a rectangle, all the pieces of the diagonals are congruent, again forming isosceles triangles, where those four match, and then these four will match. And we have this one 64 that's at this vertex of this isosceles triangle, and so if we take 180 and we subtract 64 from it, we get 116. And then we're going to divide that in half to get each of these angles. So those are each 58. Keep in mind that this angle up here is a right angle, and so if you have 90 and you subtract 58 from it, you can get the other angle, 32. So then all of these are 32s. And then to match with the one we had a moment ago, these will be 58 as well. These are both 64. And then to find the other angle that we do not know, these make a linear pair. So if you take 180 minus 64, you get 116 for those two angles. And now we know all the angles, so we have the answer to everything they could ask about. BAC, 32. DAC, 58. AEB, 116. And ADB, 58. So there's a sample rectangle problem that involves angles. Let's look at some rhombuses. Here's a rhombus example that's using angles. And in a rhombus, remember that the diagonals are perpendicular. So angle 8, we can know right away, is 90 degrees. Remember that along a diagonal, the angles that are touching that diagonal will match. So for this diagonal here, that involves the 25, the 7, the 3, and the 4. And so all four of those angles are equal to each other. So they're all going to be 25. The next thing I'm going to do is use this triangle here that has the angles that are labeled the 4 and the 8 and the 5. And a triangle should add to 180. So if we take 180 and we subtract 90 and we subtract 25, we should have what's left. 65 degrees. So that's the measure of angle 5 there. Along that diagonal, we should have 4 matching angles. So knowing that that one is 65, we can know that each of these others is also 65. So now we just have to list what we just figured out. So angle 3 was 25, 4 was 25, 5 was 65, 6 was 65, and 7 was 25. And now we have all the answers to the angles. Here's a sample question that involves some side measurements. So they said that BC is 23 and that AC is 40. That's the full diagonal. Remember that for a rhombus, just like any parallelogram, the diagonals are bisecting each other. So these are each 20 in length. Remember that the diagonals make right angles, so this is a right angle here. So what we do have is we have some right triangles inside, and we might need to use Pythagorean theorem to find a missing side. They are going to look for EB, so we are going to need to do some Pythagorean theorem. So 23 squared minus 20 squared, and then the square root of that. So x squared is the square root of 129, which is about 11.4. If you have one that you're having to round in the assignment, It is going to tell you where to round to. Traditionally, we would do a radical form, but since I believe the assignment for this is a Canvas quiz, you're going to most likely be rounding. So BE is 11.4, that's what I just solved for. A to E is 20, we just already had figured that out. And then from A to B is our other side here. And being a rhombus, which I almost just forgot what the main thing about a rhombus is, when you have a rhombus, all four sides are congruent. And so they're all 23. So AB is 23. And that's our rhombus sample. Let's look at a square example. We have a square here, and they told us that AE is 2x plus 13, and that EC is 8x minus 41. And they want us to find BD. Well, remember, being a square, it's also a parallelogram. That means that the diagonals bisect each other. And that means that these diagonals are congruent to each other. So I'm going to set them equal and solve. Subtracting 2x and adding the 41. And then dividing by 6. Now we have x. They want us to find BD. That's the length of the other diagonal. Remember that being a square, it's also a rectangle. And rectangle property was that the diagonals are congruent. So if we can find the diagonal AC, it will be equal to BD. So what I'm going to do is plug into the AE part. So 2 times 9 plus 13, that's 18 and 13. And that's 31. So if each part of these is 31, that's a length of 62, which means that BD is 62. The second part to this question has given us angle ABE. That is this top angle. And they said that it's 5x, and they want us to solve for x. Well, remember, being a square, that each angle inside of here, all of these little angles, are all 45 degrees. So we know that 5x equals 45. And so if we take 45 and we divide by 5, we get 9 for x. So those are some sample problems where we might use squares, rhombuses, or rectangles to solve using their special properties.